So for number 1, when we expand, we can first convert this radical, the cube root, into parentheses raised to the 1/3, right? So square root would convert to parentheses raised to the 1/2, and cube root converts to parentheses raised to the 1/3. So then we have the 5x to the 5th underneath. If we bring that power inside, we end up with 5 to the 1/3 times x to the 5/3, because 5 times a third is 5/3. Now, to expand, we're going in reverse PEMDAS order. So we first break up multiplication with addition. So then we have ln of 5 raised to the 1/3, ln of x raised to the 5/3. Then e comes last, the power comes down in front of its term. And that's how we end up with our answer, 1/3 ln 5 plus 5/3 ln x. Similarly, for number 2, it's the same concept. We're going in reverse. We break up division first with subtraction. Now be careful. You're subtracting the entire log base 5 of the denominator. So when you do log base 5 of the top, log base 5 of x squared, minus log base 5 of the denominator, which is y squared z cubed, you have to be careful. We need to distribute or negate everything that was in our denominator. So then when we break up the denominator, we break up the product, multiplication with addition. So if we look at this, we have log base 5 plus y squared, first term, plus z cubed. And then the power comes down in front of its term. So we have 2 log base 5y plus 3 log base 5z. And then we need to distribute the negative in. So when we distribute the negative in to both terms, it becomes negative 2 log base 5 of y and negative log base 5z. And then in front, we just bring this power down in front, bring the exponent down in front last. So for that term, we have 2 log base 5x minus 2 log base 5y minus 3 log base 5z. The only real trick there is that sometimes people forget to negate all terms in the denominator. Okay, so for number 3, if we're trying to condense, they're both common log, log base 10. Remember, when we don't see a base, we know it's base 10. So subtraction goes with division. The expression that comes first goes in the numerator. The expression that comes second goes in the denominator. Now for this one, we can factor the numerator into x minus 7, x plus 2 in denominator, difference of squares, x plus 2, x minus 2. And the quantity x plus 2's cancel. So we have common log of x minus 7 over x minus 2. Now, if we're going in reverse for number 4, remember, when you're condensing something, you do go in PEMDAS order. The e means we're going to bring our powers back up first. So the 2 on top of the x, 6 on top of y, and 2 on top of the square root. So we did that right here. Remember, square root and squareds cancel. They're inverse operations. So then when we're looking at these pairs, we move from left to right. So we first look at the first set. It's addition, so it goes with multiplication. And we multiply the obs. So it's x squared times y to the 6. So it's ln of x squared times y to the 6. Okay, so we consolidated those two. Now we move on. And we take this expression, subtract from what's left, ln of x. And then again, subtraction goes with division. And x squared y to the 6 is in the numerator because it comes first. And the x is in the denominator. There's one x that we can cancel in the numerator and denominator, leaving one left on top, nothing on the bottom, and the y to 6 on top. So we have ln x y to the 6. So for number 5, remember, in order to solve, we need to condense first. So on the left side, they're both log base 4. We know that subtraction goes with division, so we condensed. We wrote log base 4, x plus 2 came first, so it went in the numerator, 3 came second, so it went in denominator. Now both sides have log base 4 in one term, so log base 4 gone. So we're left with x plus 2 over 3 is equal to x minus 1. Anytime I have a fraction, I focus it on the denominator to get rid of the fraction, so that's why I multiplied both sides by 3. So on the left it canceled, and we were left with x plus 2, and we distributed it on the right, and we got 3x minus 3. From there, you solve it's a basic algebraic problem, and we should get x is 5 over 2. So for number 6, remember, you need to isolate your base raised to a power. So first, we're going to add 5, and then, and then we'll get 3 e to the x plus 1 is equal to 12. Then we need to divide by 3, and then we get 4 on the right. And now that we've isolated the base raised to the power, we need to have log base e, or natural log, on both sides, right? Because natural log is equal to log base e, whichever you prefer. So now on the left, cancels. We're left with x plus 1 on the left. On the right, log base e of 4. Or if you prefer, you could say x plus 1 is equal to ln 4. Natural log 4. Then, remember, when you plug this in your calculator, when you evaluate ln 4 log base e of 4, when you put that in your calculator, remember that's a value, and then you'll subtract 1. And when you do that, you'll get 0.38 approximately. Okay, for number 7, we need to condense on the left. So they're both common log, they're base 10. Subtraction goes with division, so that's why we write log one time. The value that comes first, x plus 12, goes in the numerator. The x that comes second is in the denominator. Now that we've condensed, we have 1 log on both sides, so log cancels. Now we're left with the expression x plus 12 over x is equal to the quantity x plus 9. Similar to one before, we zone in on how to get rid of the denominator, so we multiply both sides by this x, and on the left it cancels. And then we have x plus 12 on the left, and on the right we distribute x in and get x squared plus 9x. You get all terms on one side. We use our quadratic formula, and when we plug into the quadratic formula, we end up getting negative 9.29 and 1.29. And now, if you plug in these values, especially when there's more than one, we want to check for extraneous. If I plug in negative 9.29 for x, for example, in the problem, if I go negative 9.29 minus log of negative 9.29, right in here, right away, there's error. So we have that extraneous value. So I think the fastest way to do number 8 is to get logs on one side. Of course, there's multiple ways of doing it. So when I looked at this, I said, okay, I can add this log over here, and if I add one to this side, I'll end up with this row that I just showed you. So then I can condense. They're both common log, base 10. Remember, when we don't see that number, you can throw it down there. Now I've condensed because of the addition. I know it's multiplication, so I multiplied x times x minus 9. We've simplified. Now I see log, don't want it, so cross it off. I bump the base, stays the bottom. So that's how I end up with 10 raised to the first on the right side. On the left, we need to distribute. So we get x squared minus 9x. And on the right, 10 to the first is 10. Now we have a quadratic, so we get all terms on one side. We hope we can factor. If not, we have to use quadratic formula. This is factorable. A combo that multiplies to negative 10 that adds to negative 9 is 1 and negative 10. And so then once you set both of these equal to 0, we would get negative 1 and x is 10. When we plug in negative 1, it doesn't work. That's why it's crossed off. It's extraneous, because if you look at the problem, if you go to the original where it says log x, right away, if you plug in negative 1 in that spot, you get error. Doesn't work. So the only answer is x is 10. Okay, so for number 9, remember, one method is to try to have same base. So on the left, we already have base 4. On the right, we asked ourselves, can I rewrite 64 so it's base 4? Yeah, 4 to the third power. So then we cancel out the 4s, and power to a power rule means you need to multiply. The powers are distributed if there's multiple terms. So on the left, we're left with 2x minus 5. On the right, 3 times 3x gets us 9x. Now it's down to a linear equation we solve, and we end up with negative 5/7.